When you first encounter L'Hopital's rule, there's a very common mistake or a very common trap that people fall into. So I want to make sure that you know this trap is out there so that you don't fall into it yourself. So if you've been doing a lot of practice with L'Hopital's rule and you see a problem like this, you might think, well, I need to use L'Hopital's rule clearly. So this is the limit as x goes to infinity of cosine of x over the derivative of the denominator is just 1, and then as x goes to infinity, cosine of x doesn't have a limit. So I guess that means this limit does not exist, right? Well, no, actually, this is not right. And the reason is because I can't use L'Hopital's rule here. So the trap is just going into autopilot and always using L'Hopital's rule without actually checking that you can use L'Hopital's rule. Remember, to use L'Hopital's rule, you have to get the indeterminate form 0 over 0 or infinity over infinity. But if we look at this limit, it isn't actually either one of those, right? So for this particular limit, the numerator is always between -1 and 1, and the denominator is, well, the denominator's x plus 1. Right? So this function that we're taking a limit of is always between -1 over x plus 1 and plus 1 over x plus 1, at least for positive x values. But if we take the limit as x goes to infinity, this one on the left goes to 0, and this one on the right also goes to 0, but that means the one in the middle has to go to 0. That's the squeeze theorem. So this limit is actually 0, and it has nothing to do with L'Hopital's rule. So the trap that people fall into when they get very used to using L'Hopital's rule is they use it all the time, even when they're not allowed to. So remember, if you think you're going to evaluate a limit using L'Hopital's rule, you have to have one of these two indeterminate forms, either 0 over 0 or infinity over infinity. If you don't have these two indeterminate forms, then you should probably try something else.